Hello, Kirk.
Hello. It's good
Very
to be
nice
back
to
again.
meet you 5 months later, because we talked the first time 5 months before, and our talk, even though it is in English with the Polish subtitles, broke, let's say, some kind of record. There were about 50,000 viewers who saw this talk, and the comments were very, very positive. So I hope that our next talk will reach the same level, or maybe even better.
That's amazing. That's amazing. I'm hopeful as well.
Yeah, and thank you that you accepted my invitation and you get involved in my physics of life. So the topic of our first talk will be the physics of life introduction. And so if we talk about something new, let's define it, and allow me to do this. So what is the physics of life and what it is for? The physics of life is the science that studies the nature and characteristic of living objects that absorb resources and replicate themselves, and the systems they create. What is the science for in general? According to Internet, science is used to develop new technologies, treat diseases, and deal with many other sort of problems. And as far as we know that we have a lot of social problems in the present times, I think, so let's say, created or discovered the physics of life just in order to give the tool to the humankind to resolve social problems. So it's my aspiration, but I don't know whether we will achieve it or not. So the physics of life was created to understand, among others, the mystery of how life could have arisen from chemical particles, and to understand many social processes in order to avoid their negative effects. And I would like also explain who is our dream audience, who is our target. I think that the people interested how the world works, people with some scientific inclination, generally open-minded people. People with open minds who can critically look at what they already know, who are searching, certainly not people attached to conspiracy theories. And as a second point, I would like to present, opinion about social sciences. So let me show the Richard Feynman attitude on the social sciences. He talked about this about maybe 15 or 20 years ago, but it lasts only 1 minute, so let's listen to it.
I think a kind of pseudoscience, that social science is an example of a science which is not a science. They don't do scientific, they follow the forms. You gather data, you do so and so forth, but they don't get any laws. Haven't found out anything. They haven't got anywhere yet. Maybe someday they will, but it's not very well developed. But what happens is, at an even more mundane level, we get experts on everything that sound like they're sort of scientific. Now, I might be quite wrong. Maybe they do know all this thing. But I don't think I'm wrong. See, I have the advantage of having found out how hard it is to get to really know something, how careful you have to be about checking the experiments, how easy it is to make mistakes and fool yourself. I know what it means to know something. And therefore, I see how they get their information. And I can't believe that they know it. They haven't done the work necessary, haven't done the checks necessary, haven't done the care necessary. I have a great suspicion that they don't know that this stuff is, don't know, and they're intimidating people. But I think so. I don't know the world very well, but that's what I think.
So Kirk, how we will comment this attitude? Because, I am completely I agree completely with Feynman. Nothing changed.
Yeah, I've been amazed at how people seem to assume that there are no kind of rules or laws that will actually maximize human flourishing and minimize human suffering. And I think what he's talking about here is very important. For example, we know that I met with a head of a social sciences department once, and he was, in his mind, the data clearly shows that there are some sort of, we can call them laws, laws of nature, laws of society, that we don't invent. It just seems that if we live those ways, that often correspond to high ethics and high moral principles, the society flourishes in every way. But if we don't, it's a disaster. But one other thing with regard to the social sciences is that unfortunately, and more so recently, is that people's preconceived ideas and what they want to believe are imposed on their research. And so they tend to do the kind of research or sampling that will support their beliefs, which is the opposite of the way we should do science. So it is a mess. And I think it's a bigger mess today than it was even when Dr. Feynman made his statement, because they are not doing this. Now, that's not to say there are good social sciences out there, scientists out there who are actually collecting data from a large enough sample to give reliable data, reliable information or conclusions, and they know how to do statistical analysis. And unfortunately, a lot of the mess that we see in the social sciences is also due to not doing the proper statistical analysis or not even knowing how to do it. So it is a mess, but there are, I believe, clear laws to be discovered out there that maximize the flourishing of a particular society.
I also, saw the all lectures titled "Power and Politics in Today's World," and it was lecture from University of Yale, so one of the leading universities in the world, and I expected that they will, maybe at least devote one of this lecture to the social processes which occur. But it was rather history. It was rather, some kind of analysis, what had happened, who told what, and they didn't draw the conclusion. They didn't see the cause and the result. And so because of this, I decided to make these talks to introduce to the people that there are processes in the societies which can repeat. We can, on some level of generality, we can say that they are very similar to each other. But first, may you introduce Richard Feynman, because I think that we have to show the importance of this guy who said so badly about social sciences.
Yes. Did you want me to introduce him?
Yeah, please.
Okay. Well, I've got some notes here just to make sure that I've covered everything and not missed anything. But I heard about Richard Feynman years ago. He's been famous. I did my first degree in physics, as a matter of fact, and he was famous in the field of physics. And but I didn't know that he was also interested in the social sciences or had these things to say about it. But he was born in 1918, he died in 1988, and he was an American theoretical physicist. And that's probably why I heard so much about him when I was doing my undergraduate degree in physics. But he specialized in the field of quantum mechanics and quantum electrodynamics, the physics of superfluidity of supercooled liquid helium, and as well he did work in particle physics, for which he proposed the parton model. And for his contributions in the development of quantum electrodynamics, he received the Nobel Prize in Physics in 1965, jointly with Julian Schwinger and Shinichiro Tominaga. And during his lifetime, Feynman became one of the best-known scientists in the world. And a 1999 poll of 130 leading physicists worldwide by the British Journal Physics World, He was ranked the 7th greatest physicist of all time. And keep in mind, even as a young person, this was no surprise to me. He was greatly respected. I did my first degree in physics in the early 1970s, and he was definitely greatly respected at that point. He assisted in the development of the atomic bomb during World War II and became known to a wide public, to the general public in 1980, as a member of the Rogers Commission. And that was the panel that investigated the Space Shuttle Challenger disaster, which we're probably all familiar with. Along with his work in theoretical physics, Feynman has been credited with pioneering the field of quantum computing and introducing the concept of nanotechnology. He held the Richard C. Tolman Professorship in Theoretical Physics. He held the Richard C. Tolman Professorship in Theoretical Physics at the California Institute of Technology. And Feynman was a keen popularizer of physics, both in books and lectures. And he also became known throughout his autobiography books. For example, Surely You Are Joking, Mr. Feynman, and others. So that's just a brief introduction to Richard Feynman.
Yeah, so we are just the same age, and I am probably 4 years younger than you, but we heard also when I was 17 years old, we heard on our lessons of physics that there is such a Feynman who wrote this book, You Are Just Joking, Mr. Feynman, and this is the best introduction to physics. So he was worldwide known. I think so. It's not a guy who just criticizing social sciences and he's a drunk guy from staying on the street and drinking wine. He was one of the most important physicists in the world. So now I would like to say how I understand how science is moving forward. So I will give some examples of Galileo and Newton, how they discovered the gravity. So the first, they noticed a pattern. Then they tried to find a mathematical formula that describes this regularity, this pattern. And by knowing the formula, they can know what will happen. They can predict the future. They can calculate the future. And we can build devices that will do what we want. And it happened that when we use what Galileo and Newton discovered, we have planes, we have engines, okay? We add some other scientists and we can build devices, we can predict how they will behave in the future. Of course, in the social sciences, we have a little bit different situation, but we will talk about this later. So we can predict the future provided the formula is 100% exact and accurate. However, accuracy is only in astronomy, so other sciences are using statistics and probability. And also already in technical sciences, which use the very exact formulas of Newton, Galileo, Ohm, etc., we are starting to encounter inaccuracies in formulas, which results from two barriers. The first one is barrier to objective information. We cannot see and observe all physical phenomena in 100% of accuracy. We have to estimate, we have to, just take under consideration these inaccuracies. And barrier in processing of information. We cannot build such a computer that can calculate every movement of every chemical particle in our body and then recalculate it and predict how we will behave and what we will do. Just we have not calculation power, and we will not be able to build it.
Okay, I just want to interrupt here. There's one word that I think the listener might be confused about. It's pronounced barrier, not barrier. And so if you just maybe do that one section again using barrier,
okay. So
they won't be confused.
Already in technical sciences, we are starting to encounter inaccuracies in formulas, which results from two barriers. It's okay? Barriers?
Yes, that's
okay.
Good. Barriers.
So barrier to objective observation. We cannot observe all physical phenomena in 100% accuracy. So we have to take under consideration that our observation is not exact. And the second barrier is in processing of information. For instance, we cannot collect all the data concerning every particle of our body and then make big calculations and say that we will behave in such a way because all these particles we will do this and that. And we cannot build such computers. And it's completely, technically it's impossible. So we have to estimate. We cannot have the exact formulas as Newton or Galileo discovered. And now let's go back to Feynman. There are some people who already noticed or notice social patterns, but they have the same problems as Galileo and Newton. I mean, the first people do not believe them. They cannot break through deeply rooted beliefs. And this is the example of Galileo. He showed the contemporary scientist that different objects, the bullet from musket, so from the gun, and the big cannonball thrown in the same period of time, in the same moment, they reach the bottom in also the same moment. So he showed that how heavy the object is has no importance, how long he will fall down. But the scientists of his time, they saw this, but they didn't believe because they believed what Aristotle said. So this is the first reason that the people do not believe, because they have deeply rooted, beliefs. The second is far stronger, that people in power bend to do this kind of research. They are, I don't know, afraid because they can lose their influence over people. The third, and I suppose that it's commonly accepted scientific method, blocks researchers in this direction because it is not taking into consideration the mathematical theory of game. I propose that the commonly accepted scientific method, which you can Google, will be discussed in our next topic, because I think what you said in our previous talk, that the classical physics can advance immediately because you can repeat every experiment in the same accuracy and you can get the result quite fast. However, the social patterns, for instance, the cycle of revolution, you have to analyze the whole revolution. And we have English Revolution, French Revolution, and Bolshevik Revolution. We have only 3 examples. And if we want to repeat this experiment, it costs too much. We cannot do this. Sorry. And so I would like to ask you, according to you, what is the reason that Unwin's research is so unknown?
Yes, I think it's, you've already sort of introduced the reasons here. One is, first of all, that people don't believe it, or they don't want to believe it. That's the problem. Now, we have undergone, since the 1960s, a sexual revolution and instituted a lot more sexual freedom than was, say, in the early 1900s when J.D. Unwin did his research. So the problem is that people want to enjoy the benefits of more sexual freedom, but what J.D. Unwin found and discovered in analyzing 86 civilizations and cultures and societies is that whenever sexual freedom increased, the flourishing of that culture declined. In fact, there was a tipping point, and when it crossed that tipping point, every culture, no exception, collapsed. And people don't want to hear that today because they would rather enjoy their sexual freedom and not worry about long-term problems. So it's a question of short-term enjoyment at the expense of long-term disaster. So they will actually choose short-term freedom and hope that the long-term disaster doesn't occur. Now, some of the objections, they like to come up with reasons to object to that. And the number one reason is that J.D. Unwin did his research about 90 years ago. But his research was done on history and the data of history, which has not changed in the past 90 years, not essentially. We've discovered new things, but it's always in his area compatible or the same. For example, I was a recent professor at Princeton University, upon reading my article on J.D. Unwin's findings, said that no researcher, even up to the present, has equaled J.D. Unwin's research on history. And I think this underscores one of the important points of studying history, not memorizing names and dates and who did what. And you already pointed out that's a problem. But trying to observe patterns. And J.D. Unwin observed the patterns. And he says these patterns happen, and I quote, with monotonous regularity. And furthermore, this is what I particularly love, because I think he was applying a scientific approach to his research. He gathered the data. He saw what the data said, and he observed there were three things that happened once that tipping point had been reached before the collapse. And so what that allows us to do is we can use them as three predictions, like we do in a scientific theory. We can use those three predictions to test to see whether it's true in our case, because in our case we have a whole new sexual revolution. And as you mentioned, we can't really set up the experiments ourselves because they often involve tens of thousands or even millions of people over a period of 1 or 2 centuries often. So the experiments cannot be done very easily, but the observation of the data of history can. And what we're seeing now is that all three predictors have already taken place. So we can be more confident that in fact our culture will collapse if we just continue down the road that we are. But it has not become very well known because people do not want to believe that's true. They think we will be the exception. Or I would rather have sexual freedom than believe this. And so there's a lot of denial, or they simply deny the research so they can continue on. And these are some of the problems that you already mentioned. And often some of the denial is, and maybe the most influential denial, is at the highest academic levels by people who themselves are denying the research because they wish to enjoy the short-term benefits of what we have today in the way of sexual freedom.
Okay, so let me now just enlist all the patterns I discovered, I collected. Maybe they are not all of them, but some of them. So, for example, the process of debasement of money made by ancient Romans, made by communists, Democrats, tyrants, and it repeats itself. So it's a process. You cannot deny it. That it's just regularity. It's a physical law. But because the government profit of this, they ban to talk about this in the right manner. So they just switch. They are not saying we are not debasing. It's not a debasement of money. It's just rising of the prices by producers. So the fall of Rome, the fall of USSR, the fall of Polish People's Republic, all the same. The process is you can precisely define the stages of these falls. Social cycles, John Glubb's cycle, Tytler's cycle, the physics of life, social cycle, which is a general cycle. I just make it more general in a higher point, and it encapsulates all this John Glubb's cycle and Tytler cycle. not natural tendency of socialism. When you introduce socialism, I mean, if you debase money, if you give this money to the people, saying that you help them, it just drives the society to the stage of the flock of cows, or how you name it in English, group of cows.
Herd mentality.
Yeah, herd mentality, you know. So the people became less responsible, they less active, and they follow the rules, even unconsciously and eventually economy collapses. We have Ron John's experiment. We have cycles of revolutions I already mentioned. We have the behavior of those in power in tyranny and democracy. Behavior according to the external conditions, you know. So I would like also add that many proverbs embody life regularities. For example, no pain, no gain. It is very well known in physical sciences supercompensation phenomenon. It's just basing the foundation of the physical training on making your ability higher, to put it on a higher level. Let's summarize. We have a lot of such patterns, but these patterns are not known in the societies. Only few people, you know, only, let's say, I would say less than 1% of people are talking about this. Why?
Yes, I think, here's my theory, here's my perspective, and the reason they don't want to talk about it, or that they aren't even aware of it, is that in physics, we are often looking at external objects like apples falling out of a tree, or a spacecraft navigating around a planet, or a chemical reaction, and it's kind of separate from us. But when the social sciences, is talking about us and maybe changes in behavior we need to make or we need to agree with. And there you begin to see a conflict, because we have our own selfish motives. A government might inflate their currency for short-term gain, again, for whatever reason, positions of power, or to look good to their population. But it's when we are involved in the experiment, it makes the experiment much more difficult to accept, because we have our selfish motives that are always we have our biases. It's probably the social sciences are more susceptible to personal bias than just say physics or chemistry, where it's not personal, what we see, what we observe, it's all external. Social sciences have implications when we study the patterns of history, and a lot of people just don't want to live their lives that way. In one respect, I think of raising children. When we raised our children, there's a lot of discipline goes into raising children to help them become productive, healthy adults. But people assume that once we become adults, we can do anything we want. But the patterns of history tell us that some of those things we want are destructive in the long term. And so that causes all sorts of bias to occur in the social sciences. And people don't want to publish their findings, or maybe they do publish them, but no one is interested in reading them because of the personal bias involved in what we want to believe about ourselves and what we can do versus what the patterns of history clearly indicate to us.
Kirk, you sum it up perfectly. And I would like to introduce the next topic. What do you think if we discuss the commonly known scientific method, you cannot Google it, and its application to social sciences? Because I state that this method is useless as far as life sciences are concerned.
That sounds like a very interesting topic, Jan.
Okay, so thank you very much for this discussion we had today, and we invite our viewers to our next talk, probably in 2, 3, or 4 weeks. Thank you very much.
Thank you. It's a pleasure.